Hello everyone. So in our last lesson we actually finally changed our um, logic a bit, and we are now using interfaces, so we no longer need to cast to our specific base classes for us to call the functions. Okay, so now that being done, today we'll be learning how doors work in video games. Okay, so for that let us understand how a door logic works. Okay, so let's say this straight line represents a door that is closed, right? And this door to be opened will either be opened in like this. It can be at an angle. I'm just drawing it at a 90-degree for just visual purposes only. So the logic is, so let's say our door has a specific rotation and location in the world. By default, let's say it is 0 0 and 0 location, and rotation is also 0 0 and 0, right? So now how we can check this, I mean change this to this open door would be just to have the location would be same, right? Just we'll change the direction to be, let's say, 90 degrees. So once this is 90 degree, it will open the door like this, right? So we can just use a function over here that is set relative rotation, and we can just have it 90 degrees. So but this way we can only do doors that open one way, right? So that is just set it to 90, and then again once it's open, set to this, we use a maybe a flip-flop, and then again we set it back to 0 0, and then the door closes, right? This is one way. Okay, and the second way would be, let's say our pawn is here, right? So what we can do is we can get something called the um forward vector, right? So this forward vector, what does this forward vector get us? This forward vector gets us the forward direction of an actor. So if we get the forward vector of our character, which would be this one, and the forward vector of the door, which would be this one, right? So if we get this and this, so now when we open it with accordance to this, and we're still opening the 90 degrees, but what we'll do is we'll multiply this with the dot product of these two forward vector. So forward vector of this actor and forward vector of the door. So when both of them are at the same direction, it will result in something of positive, let's say positive 1, right? Let's say the value would be positive 1 when they are actually are on the same side. So we'll do it on the positive 90 degrees, and it will open the door on this side particularly, right? But now let's say our character now is on this side of the door, right? Is on this side. Actually I'll just draw it again. So let's say this is the door again, and this is the open door. Our character is over here. The door forward vector is still this one, right? But our character forward vector is on the other side. So now if I get the dot product of these two, this will result in something, let's say -1, right? My bad. Yeah, the dot product will result in, let's say, -1. And now if we are to add or set the relative location to 0 comma 0, and what we'll do is we'll multiply this dot product into 90, right? So what will happen is, depending on the dot product, if we are on the opposite sides, it would be minus 90 degree, it will open on this side. And if we are on the same side, if the player is over here and facing the same direction, same forward direction as the door, and we get a positive one, and the door will open like this, okay, in the positive 90 degrees. So that is how the door logic works. But simply doing this is not enough, because then you'll just see the door like this and like this, you know, in an instance. But we also want to have it open smoothly like this, slowly, gradually, from here, then to here, and finally to here, right? Something like this. And even while closing, we'll have something similar. The first door will be over here like this, and then it closes, then like this, then third like this, and then finally close like that. So the way to achieve this slowly over time would be using a timeline. Okay, so we'll be working on that as well. So let us get started. Okay, so the first thing would be, in our horror folder, we'll make a new folder and we'll call this the door. Okay, and we'll create a new blueprint class of the type actor, and we'll call it bp underscore door base. Okay, and now since we already made the interfaces, we'll go to class settings and add the interface bpi interaction. Okay, so we now have the functions as well, begin interaction and interaction. And for these, we'll go to the pickup base, and from here in the interactions we had the begin interaction and the end interaction. I'll just copy this, okay, because the logic will be the same, right? I'll copy these, come to the base door, confirm. Actually, we do not need the cancel pickup, delete that. For the end pickup, we need the interactions. I'll create the character reference, interaction widget, we'll add that. So let's make the static mesh first. This will be our door frame, and then we'll add another static mesh, and this one will be our door. And we'll have two widgets, will be the left interact widget IW, and then we'll have, actually over here just make it to, yeah, keep it to world, and this one will be the pickup widget. And then I'll just duplicate this and call it the right interact widget. Okay, so right interact widget and the left interact widget, yeah, set it into false. Pickup widget, so for this we need the begin play. I'll put this on the side. So on the begin play, we'll take both of these since we need them both. Go to the pickup base and event graph, you need to copy this. Okay, go back to the door base. So this one would be the left one, and create UI left interaction widget. Okay, now just copy these three things. Actually, we don't need the left one, make it over here, and then I'll promote this as UI right interaction widget. Okay, since we're done with this, again I will just drag and drop both of these and then close it, right? And the left is done, so I need to do it same with the right is valid. Copy this. We need to the image. Okay, the event graph up above UI pickup widget, that is fine. Okay, let's go to widgets, pickup widget, image. Yeah, we have the image. What's wrong with this? Okay, okay, the right one became a okay. Oh right, that's why I drag and drop from here, right? So I actually have to drag and drop from the variable section over here, convert to validate get the image and the slit brush, and we're done. This one will be the right one as well, but again same thing, copy paste from the one below, and the logo is there, and begin interaction, and an interaction has been set. Again I'll just cut this one out, create a new graph, call it interactions, and paste it over here, right? So now that we have set up the door part, wow, this is big. Make this to 50-50 and the right one as 50-50 as well for the draw size, right? And the door frame over here, you can just click the door frame, and this one will pop up because it's already it already comes with the starter content. If you had not added the starter content by default, what you can do is open up the content drawer from here or control spacebar, then come over here on the add button, click it and add feature or content pack, and from this pop-up, click on the content over here and starter content, add to project. Okay, and it will be added. So that is done. It's in the door frame, we added the door frame, and over here we'll add the door itself, and then yeah, place it properly, and on the left hand side and the right hand side, right. Make it to 10,10, I guess. Yeah, so this one will be like this over the door, and this one will be 10,10 again, and rotate this one to 90, sorry, 180, and have it by the door here like this. So we're done on both sides, right? And another thing, go to the door over here, open the door, and over here you see the starter content doesn't have a collision, so add a box simplified collision to it, otherwise there will be no interactions. Okay, so now let's go to the door base and drag and drop it over here, right? And let's see if we can interact. Actually, as you can see, yeah, you can interact with the this one. It shows red. Yeah, it shows red. Another thing would be go to the door base. Both of these should be hidden in game by default. So when you play the game, you see nothing, but once you try to interact, you can see. So another thing would be in the interaction, we have the interact distance, make it to 75 ish. So basically you can't interact with this until and unless you crouch, so we'll implement that as well, but right now this is fine. See, you are near to the door, only then you can interact with this door, okay, which is good. And over here as well, this is good. And the next thing we'll be doing in the is door base would be the logic, and the logic would be on the begin pickup, and yeah, only begin pickup, because we'll not have an end pickup on the door itself. So okay, let's start from the base. Okay, so first things first, this one will be on a flip-flop when we interact, and now we'll be interacting with the door itself, right? So what we can do is set relative rotation, and like I told you before, we'll be doing it 90 and then 0. Okay, so to understand, let's see how the door works. And now if I go near the door, interact, press E, opens the door. I come here, press E, closes the door. See, this is instantaneous, as you can see, door opens and closes, right? You can pass through the door, you close the door, you can't pass through, right? Open the door again, you can pass through, which is fine, but it doesn't look that good, right? Because this is instantaneous like this. So what we'll do is, right now we'll do a timeline. Okay, so we'll add a timeline, and this one will be open door timeline. Okay, we'll add a float track, and this one will be open alpha, and make the length to be 1. Now press shift and left mouse button for to add a track on the curve. Okay, so add another shift and left mouse again to add another point on the graph. So the first one will be 0 0, and the second one will be at 1 and 1, right? And then press this, both of these, to zoom to fit both the points within the screen itself. Now you can use your mouse wheel to scroll out. Okay, now you can have it as linear, otherwise just click both of these, control and left mouse to click both of these, and then right click to use auto. And then what you can do is you can make the curve to be a bit smooth like this and not exactly linear. So I'll just copy paste another timeline and just rename this to as close door, and also rename this to close alpha, right? So from here, what we'll do, play from start, and on update we'll change the door, and we'll create two things. The first one will be open angle. So this angle can be anything that you wish. So I think 120 would be better. And this, what we can do is lerp the float, and the alpha will be over here. And since this is open door, B will be the final, will be the open one, and the first one will be the closed. So we'll create a new variable and we'll call it close angle, and this one will be another float, and this one by default will be 0 0, right? And then for the close one, we'll just change this, the open alpha, open angle will be the first one, and then we close it, right? So now let's play and see, you open the door, it opens smoothly. You close the door, it closes smoothly, right? Opens smoothly. Actually, yeah, I'll bring it over here like this. Door opens really well and door closes really well, right? So this is good. The other thing is, you see how it pushes the character like that. So what we'll do is, whenever we are interacting, what we'll do is we'll get the door in itself, we'll set collision enable to no collision, right? And once it has finished, we can do a collision enabled, right, while opening and closing. So when we do this, it becomes much more smoother and really well, opens the door and closes the door through you, see. But yeah, once it closes, you cannot pass through the door again. Once it opens, you cannot pass through this, right? But while closing or opening, you can easily pass through the doors, see, which is really good. And this concludes our first door in itself. Okay, and I'll just cut this one and go over here and put the interaction over here, and I'll call this door logic. Click on the show bubble when zoomed. So this is how the first type was made. Okay, and now what I'll do is I'll come over here, and from the door base I will create a child blueprint, and this one will be um, bidirectional. Yeah, bidirectional door, so it will open on both sides, right, left and right. So over here, since everything was done on the parent itself, the only thing we need to overwrite would be our begin pickup. Okay, so let's override this begin pickup, and again we'll have this on our interactions graph, and I'm gonna copy this thing. Okay, actually copy the whole thing like that, create this custom event, and what I'm gonna do over here is get actor forward direction, and then I'll get the character reference, make sure this is valid, right? We'll get the forward direction. If it is not valid, we'll just directly open the door, doesn't matter which way. And if our character reference is valid, we'll get the dot product of both of these, and we'll promote this to a variable, and we'll call this the dot product. Okay, and actually, yeah, don't do that because character reference will always be valid. Now what I will do is we'll get the dot product, and while opening we'll multiply this and put it together like this, and while closing again we'll do the same thing. We'll get the dot product and plug it in like this. I'll make more room so it's a bit cleaner. and like this, another one. Okay, and now let's compile and save and check our bidirectional door as well. So the logic is the same like I told you before starting off the coding part. So now let's go ahead and check this bidirectional door. I open this door and the door closed. Actually, yeah, this one will stay same for both the opening and closing. So at the time of opening is where we'll store this dot product, right? Otherwise we'll have the problem that we encountered right now. So once we open this door on this direction, it doesn't matter where we close it from, it will close from that particular direction. Again, see, bidirectional, we can open the door, I can close the door like this, which is fine. Even if I go behind this and close it, now it will just close from this direction in itself, because we are setting the direction of opening the door while actually opening the door in itself. So it doesn't matter which direction we are in while closing the door, we'll always close it from the rotation that was already set while opening. Okay, so that's why we're checking the dot product only during the opening of the door. And again, this one will be door open and this one will be door close. Okay, and that was the door logic in itself. It was quite simple, and in our next lecture I think we will try to work with the crouching functions, maybe crouching, maybe, or else we can actually go ahead and check with inspection system as well. Okay, so thank you guys, and hope to see you in the next lecture.